Assalamualaikum and good day to everybody. My name is Siti Fatimah binti Haji Ahmad Zabidi from FIS, Faculty of Industrial Science and Technology, University Malaysia Pahang. Okay, welcome back to the applied calculus. Remember last time we have talked about applications to integration 5.1. We talk about finding area, and then 5.2 part 1 we have talked about finding the arc length using integration. So today we are going to find also using integration 5.2 part 2. We are going to find the surface area of revolution using integration. Okay, area of surface revolution part 2. So if we want to find the area of a surface of revolution about the x-axis, we have a formula for this, but the function f should be smooth, okay, non-negative, and on the AB, then the surface S of the surface revolution that is generated by revolving the portion of the curve y equivalent to fx between x equivalent to A and x equivalent to B about x-axis is defined by this. Okay, this is the surface area of revolution about this x-axis. So notice that we have this one here. This is the one that we learned before. This is the one that we learned to find the arc length. Remember? So today we are going to use this formula. So how to use that formula? Alright. Remember remember the ds formula that we have been using for the arc length. So the same formula we are going to use here. So now we want to find, let's say we want to find the surface area of that piece here. So we need to find the circumference. So the circumference of this circle here, this circle here, we have this radius. So the radius is y. Okay, radius is y. So we multiply 2 pi y, which is the circumference. We multiply by the small, this small ds here. So we will get the surface area of that small strip. So to find all the surface area resulting from this function revolve about this x-axis is to integrate from a to b 2 pi y square root of 1 plus dy dx squared dx. Okay, so let's look at one example here. So the example here is to find the area of the surface that is generated by revolving the portion of the curve here. So we have the curve here. We just need to find a portion between when x equivalent to 1 over 4 here and x equivalent to 3 over 4 about this x-axis. So we are going to use the formula. Alright, let's look at this example again. We have y equivalent to square root of 2x minus x squared. We want to revolve it about this x-axis for the portion x from 1 over 4 until 3 over 4. Okay, so what we will do will be to find dy dx first. So first we will rewrite this as 2x minus x squared to the power of half, so that we can find the derivative. Dy dx will be equivalent to half which is the power rule, 2x minus x squared, and we need to reduce the power by 1, and remember to differentiate again the one in the bracket, which is 2 minus 2x. Okay? So then we simplify our dy dx will be equivalent to half 2x minus x squared to the power of minus half, and we factor out the 2 to get 2 here and 1 minus x, so that we can cancel this 2 and this 2 here. So our result will be 1 minus x, divide everything by square root of 2x minus x squared. Okay? So then we need to square this and add 1 to that. So let's look at that again. Now we need to remember, just now we have to square the dy dx. Okay, we squared the dy dx. We will get 1 minus x squared, divide everything by 2x minus x squared. Okay? So then, if we add 1 to that, so 1 plus dy dx squared, we will get 2x minus x squared divided by, okay, plus 1 minus x squared over 2x minus x squared. Therefore, 1 plus dy dx squared will give us, we just expand this one, we have 2x minus x squared plus 1 minus 2x plus x squared. Divide everything by 2x minus x squared, and we can cancel this one and this one, and we can cancel this and this. Also, we have only 1 over 2x minus x squared. Okay, let's continue how to find the surface area. Now, at ds, remember ds, we have the small s here is equivalent to square root of 1 plus dy dx squared, which is actually square root of 1 minus 2x minus x squared, and that is equivalent to 1 over square root of 2x minus x squared. Okay? So to find s, okay, remember what is the formula of s just now? Formula of s is equivalent to the integration from a to b 2 pi y square root of 1 plus dy dx, the whole thing squared, dx. Okay? So let's find the, we know the formula now. So we just substitute this function here, in here, and try to evaluate this. Remember, a is 1 over 4 and b is 3 over 4. Okay, so now we integrate, substitute values. A, s now, be equivalent to integration from 1 over 4 to 3 over 4. We have 2 pi just now. and then our y is square root of 2x minus x squared, and then we multiply by the s just now, which is 1 over square root of 2x minus x squared, and we integrate that with respect to x. Notice that here, this can cancel with that one, okay? This one and this one is equivalent. So we end up getting the integration from 1 over 4 to 3 over 4 2 pi. And we integrate this with respect to x. Alright? So we will get 2x. Integrate that, we'll get x. Integrate from 1 over 4 to 3 over 4. And we substitute values in. We have 2 pi. Substitute the upper limit, 3 over 4, minus lower limit, 1 over 4. And we will get 2x, 2 pi, multiplied by, this is actually 2 over 4. 2 over 4 is actually half, and that times by 2 will give you only pi. Okay, that's for number 1. Let's look at how to find the area of surface of a revolution about this y-axis. Now this one, we need to know that the function is in terms of y, and that function must be smooth, non-negative on the interval CD. Then the surface area S of the surface revolution that is generated by revolving the portion of the curve x equivalent to Fy between y equivalent to C and y equivalent to D about the y-axis is defined by this. Also, this one is 2 pi x. Now, x here is the radius, okay, and this is the small s here. Remember the small s, and we integrate with respect to dy. Okay, let's look at the function, the formula again. Okay, let's look at the formula again. Remember, to find the surface area of a revolution, when we revolve portion of this curve here about this y-axis. Notice that when we subdivide this into small parts here, we have this small strip here, and to find the area of this small strip here, we are actually finding the length of the circumference. We multiply by this ds, so we get that small area of this strip here. So we integrate from C to D. Okay, let's look at one example. Now suppose we want to find the area of the surface that is generated by the curve here, portion of this curve here. So this is the curve here, and we want to find just a portion of this curve, which is from y equivalent to 1 to y equivalent to 4. So y equivalent to 1, so this part here, until y equivalent to 4. 1, 2, 3, 4, until this one here. Okay, so portion of this we want to integrate using, we want to find the surface area of revolution. Now let's look at that problem and try to solve it. Okay, but now we need to write the function in terms of y. So the x will be the subject. So we write x equivalent to square root of 4 minus y. So y is in between 1 and 4. Okay, so first of all, we will try to find the dx dy. So dx dy dx dy. So we need to differentiate this here. So we actually need to write this, we need to write this as 2 times by 4 minus y to the power of half. So we will do the derivative using power rule. Okay, you have 2 times by the power, and then we need to reduce the power by 1. Okay, and don't forget to differentiate the 1 in the bracket again to get negative 1. So this have negative here because of that negative y. So if we differentiate the 1 in the bracket here, we will get minus. So we put minus here. So we will get negative 4 minus y to the power of minus half. Okay. Then once we get this, to find ds, we should add 1 to that. So we will square this. Okay, we will square this first. Square this first. Okay. D x dy. Okay, we square this. We will get, okay, square this. We will get 4 minus y. Okay, to the power of minus 1. To the power of minus 1. Okay. So add these two, dx dy, the whole thing squared. We will get 1. We will get 1 plus 4 minus y to the power of minus 1. So this is actually 1 over y minus 4 minus y. So we will get the same denominator, 4 minus y. The upper part will be 4 minus y, and we add 1. So we will get 5 minus y. Divide everything by 4 minus y. Okay, let's use it to find the surface area. Okay, we find it to find the surface area. So now surface area S, remember the surface area formula? Surface area is equivalent to integration from C to D. Okay, C to D, 2 pi. Remember the x is the radius, and this is the small s. 1 plus dx now dy. We differentiate x with respect to y now, because we want to revolve about the y-axis. So dy. So we will get integration from 1 to 4, 2 pi. Okay, now x here, we have x here just now. We have, this is x here. We change it to 2 times by square root of 4 minus y. We multiply by square root of 5 minus y, divide it by 4 minus y dy. Okay, notice that this one and this one can cancel off because this is the same. Okay, so we will get square root integration from 1 to 4. We have 4 pi square root of 5 minus y dy. Okay, let's continue how to solve it. So remember now, we need to solve this one. So how to solve this one? Now 4 pi is just a constant, so we can put it out. We can pull it out here and put it outside the integration, and then This one, square root of 5 minus y. We want to integrate, we use substitution method, because if we use this as u, then we will find that du is actually minus dy. So we can substitute that with dy here with du. So of course we need to change the limit of integration. There are many methods of doing this. You can also change the limit of integration, but what I'm going to do now is just to integrate this without the limits. So then after that I will substitute the limits again. Okay, so we will integrate without the limit first. Let's integrate that without limits. Okay, without limits we have now let's integrate that without limits. That means integration of 4 pi of square root of 5 minus y dy. So I'm not going to put the limits yet here, but what I'm going to do now is to let u to be 5 minus y, so that when I find du dy, I'll just get minus 1. That means dy is equivalent to minus du. Okay, so we can change that dy here to minus du. Therefore, the integration of 4 pi of square root of 5 minus y dy can be changed to, okay, we change everything to u now, 4 pi, and then we have u to the power of half here. Now dy, we change it to minus du, okay, but minus here is just a constant, and 4 pi also a constant. We can pull it out this outside the integration. Okay, let's continue that on the other slide. Okay, so just now we just change everything to u, so we will get s to be minus 4 pi. We put it outside the integration, so we substitute everything in terms of u. So what do you have with the du here? Okay, so when we integrate, we will get minus 4 pi. So you remember, when we integrate, we increase the power by 1. So u will be to the power of 3 over 2. We divide by the new power. So we divide by 3 over 2. And we have to add c. Because we don't have any limit here, so we need to put c. That's okay. So we will then have it to be equivalent to, because this one is 3 over 2 is the same thing as 2 over 3. So 2 multiplied by minus 4 will give us minus 8. So divide by 3 pi, and u is to the power of 3 over 2 plus c. Okay, so we will get minus 8 over 3. We change u back to 5 minus y to the power of 3 over 2, and we add c. Now we use this in the integral, and then we will find the surface area. Okay, let's do that again. So now we need to find the surface area from 1 to 4 just now. From 1 to 4, we have 4 pi, and then we have square root of 5 minus y dy. So that one is equivalent to, we just now found that this is equivalent to, remember we have minus 8 divided by 3, and then we have pi here, and we have changed that u to 5 minus y to the power of 3 over 2, and then we need to evaluate from 1 to 4, remember? So you just substitute values in, and then we should get the answer. Okay, let's do that on the other slide. Okay, so on the slide we have to just need to evaluate. So we will get S equivalent to, remember we have the constant just now is minus 8 over 3 pi, and we have 5 minus y to the power of 3 over 2 from 1 to 4. We have that. Now substitute values in. We will get minus 8 over 3 pi. We substitute 4 in first. 5 minus 4 will give you 1. So that's 1 to the power of 3 over 2. We minus, now we add, we substitute 1 in, for 5 minus 1 will give you 4 to the power of 3 over 2. But 1 to the power of 3 over 2 is just 1, so we will get minus 8 over 3 pi, and then we have 1. When we substitute, if we have 4 to the power of 3 over 2 is the same thing as 2 to the power of 3, which is actually equivalent to 8. So we have 8 here. Okay, so this is just 7. So 7 times by 8 will give you minus 7 here. So this is minus 7. So minus and minus will give you plus. So you get plus 56 over 3 pi. So this is, I call it unit squared for surface area. So that's how we find surface area of revolution about this y-axis. I think that's about all for today. So we can continue next time finding another application. We will find some interesting application also to find volume of revolution. So till then, I'll meet you in the next episode. Thank you so much.